Welcome everyone to the second of 4 webinars on exploring vulnerability assessments for the Four Corners and Upper Rio Grande regions. Today's webinar is on mule deer and elk. My name is Mary McFadden, and I'm the Southern Rockies Landscape Conservation Cooperative, or I'm with Communications and Outreach Specialist, and I'm going to be the host for the webinars. Megan Friggins, who's with the U.S. Forest Service Rocky Mountain Research Station in Albuquerque, and her colleagues will be leading the webinars. Before we begin, just a couple of reminders. Please mute your phone upon once you've entered the webinar. If you hear odd echoing, please turn off your computer speakers. That can be done by selecting that green speaker icon at the top of your screen. Also, if you haven't yet, please introduce yourself in the chat box. We'll have a couple minutes to do that during the introductory slides that Megan will be providing. And just to let you know, we are recording this webinar, and we'll let you know when the recording and presentation slides are posted on the Southern Rockies LCC website. If you'd like to learn more about the other 2 upcoming webinars, as well as the Adaptation Forum workshops, you can open up the web links that are located in the lower left corner of your screen. All right, Megan, we're ready to go if you are.
All right, I am. Thank you. So I'm Megan Friggins. I'm with the Rocky Mountain Research Station, and today I'm talking to you from Albuquerque, New Mexico, where I'm stationed, and I'm joined by Zeidel Wasserman, who's with the Ecological Restoration Institute at Northern Arizona University in Flagstaff, Arizona. And so we're going to be talking to you about the results of our vulnerability assessments for elk and mule deer in the Four Corners and Upper Rio Grande landscapes. This is our first opportunity to present the results of this data, and it is a work in progress, and so we really hope that we can get some feedback and comments from the folks that are participating today to help us improve this as we move forward and complete our assessment. So I expect today we'll take about an hour in this webinar. We have extra time if we need it for discussion, but I'm going to briefly overview introduce, I guess, this project and the assessments in these landscapes. Then I'm going to take a little bit more time to talk about the methods underlying all of the assessments. And then Zeidel will take over and present to you kind of the fun stuff, the results of what we have so far. And then I'll close up with a couple takeaway slides, and then we'll have a period of time for questions and answers. And so you're welcome to ask questions at any point in this presentation, and we can try to pause and answer them. Please feel free to make comments. We specifically ask for information at certain points in the presentation, so we'd really appreciate it if you could put your 2 cents in at that point. Oops, excuse me, I'm hitting the wrong thing. So for today, our goals are to provide an overview of the assessment results and to give you, the audience, a foundation to understand what we've been doing and how we can use these products moving forward. We really hope that we can get some information from the audience with respect to additional data sets or maybe needs that can be incorporated into these assessments. We would like to incorporate this feedback from today's discussion or any follow-up emails in preparation for some upcoming adaptation forums where we'll really drill down into these assessments and hopefully begin to use them to try to identify some management strategies within the Southern Rockies LCC. So briefly, I'm just going to review kind of how these assessments came to be. As many of you probably know, the Southern Rockies LCC has engaged in an adaptive management framework to develop shared conservation objectives and landscape scale adaptation strategies, and they've engaged in a number of activities towards these goals. One, they have identified focal resources and landscapes through a variety of mechanisms within the Southern Rockies LCC, and some of these graphics here are showing you their adaptive management framework and the focal areas where there's work ongoing. Our 2 that we are interested in for today's talk, of course, is the Four Corners and the Upper Rio Grande. So we partnered, the RMRS and the Southern Rockies LCC partnered to create vulnerability assessments for focal resources identified through a variety of meetings and in some adaptation forums that we had in the spring of 2016. We are planning a second round of adaptation forums for each of these, one for each of these focal areas at the end of August and beginning of September of this year. And so we're really primed for presenting the assessment results and perhaps modifying them to really maximize their utility in these upcoming adaptation forums. Oops, I keep hitting the wrong thing, excuse me. So this is a list of the focal resources that we focused upon. We have first stream flow, native fish, and riparian corridors. This was the topic of yesterday's webinar, which is available as a recording if you're interested in that. Today, of course, we're talking about mule deer and elk. And then in a couple weeks, we will have presentations on the results of our pinyon juniper woodland and sage steppe habitat assessments. So the items in that blue font that you see there are items that were added after our first series of adaptation forums. This is given feedback from participants that identified these as potential interests. The ones that are in black were the original focal resources identified by the LCC. All right, so now I'm going to talk a little bit about the methods of the assessments. But first, we would like to poll the audience out there right now. And if you could go ahead and select some responses here. We want to know whether or not you actually may have been present at the initial round of the adaptation forums in 2016. If you are planning on potentially coming next month to any of the future adaptation forums. And then we'd really like to know, where you're working, what are you interested in. So I don't think this will take too long, but it looks like many of you may be new to the assessment. I don't know if you've heard where you've heard about these, but that is actually a good thing. We'd love to continue to expand our reach and get the information about these assessments out there because feedback is really helpful for improving them. So it looks like there are some people planning on attending the upcoming workshops. Maybe we can convince more of you too by the end of this presentation. Okay, great. And then folks from all the different regions. So, okay, really great. Okay, thank you. So now we'll move on. And I'll try to move through this fairly quickly. This is information that we're presenting in all of the webinars in case you're just popping in for one. But it's important information, but I know the results are probably the most interesting part. So I'm going to show you here our framework for our landscape level vulnerability assessment of focal resources. And I haven't explicitly said this, but the ultimate outcome of this project is to create spatially explicit vulnerability assessment products, and so maps essentially. And so we're doing this landscape level assessment. And what you can see, let me engage my pointer here. Let's see, yeah, there we go. So what we have here are 3 elements of our vulnerability assessment, and these are pretty standard elements for any vulnerability assessment. I think especially if you're dealing with climate change vulnerability assessments, you see these. We're not concerned only with climate change. We tried to look at a variety of threats and issues for the focal resources. Then I have definitions here as we're using them for this particular project. And then I have some examples of the types of spatial data and indicators that we use to measure each of these elements. So to go through this, we have exposure. This is our external threat to the target species, system, or place. And if you recall, we have a diverse set of targets that we're doing assessments for in this project. And some examples of the type of things that we looked for data on human impacts. This could be things like development or urbanization, natural disturbances like fire, and then of course climate change is often a issue for many systems. Sensitivity are the qualities that make the target more susceptible to negative impacts from a disturbance or threat. And so this can be kind of intrinsic traits or conditions associated with an increased negative response to some exposure, some disturbance. It could also be considered an indicator of potential cost of disturbance, and this is particularly true if you're incorporating values into a vulnerability assessment. Then we have adaptive capacity. This is the ability of the target to cope with a disturbance or threat. And again, this can consider intrinsic traits or conditions that are associated with resilience or ability to bounce back. You know, we can use a lot of different terms for that. It can also be considered the potential for management intervention, in that if you have a situation where you can, through some management action, reduce the sensitivity or exposure of some resource of interest, then you might consider that particular area as having a higher adaptive capacity. And so there's a variety of ways that we can look at these different elements and how they're put together. And a final assessment really depends on the scope and the goals of the user. So for instance, many species level assessments will really focus on these traits, these intrinsic traits and conditions when they are looking to measure sensitivity and adaptive capacity. Other types of analyses, a really good example is a Forest Service watershed assessment, really wanted to include the provision of ecosystem goods and services. And so they really focused on kind of the value and the potential cost of losing particular watersheds to some disturbance in their assessment. And then I'm currently working on a project that is using a vulnerability assessment framework to gauge how management actions can influence fire-climate interactions and the vulnerability of landscapes and even the fire regimes themselves to changes in climate. And so the target or adaptive capacity measures almost entirely deal with the potential changes of different treatments on the landscape for reducing exposure and sensitivity. And so again, how you select your elements depends a lot on the goals of the assessment. And so as we go through these webinars and talk about results of how we did these assessments, you'll see that we really tried to be inclusive and consider the data available and where it would fit best, what kind of measures that we could use. And in some cases, we use a whole combination of these. So here I'm showing you the primary steps. I'll go over these in more detail in the next couple slides, but the primary steps that we use to quantify vulnerability. Here are how the elements are actually put together. So you have your exposure measures and your sensitivity measures, and those are usually drawn together to give you an estimated impact. And then you actually assess your vulnerability by considering the adaptive capacity of your system, which is, it kind of modulates this impact. So if you have high adaptive capacity, that impact will have less influence, and therefore you would say your system is less vulnerable. So the first step to this is to identify and gather your data. That one, you want to assess its relevance for representing one of these elements, and two, you need to assign it to one of these elements. And so some types of data could actually fit equally, well, maybe not equally well, but could be considered an element of exposure or disturbance, or it could be considered an element that's indicating some state or sensitivity. And so where you put a particular data set is often a function of the type of data it is, and then again, what your objectives are in your assessment. Do you want to really highlight those sensitive areas? Do you want to try to highlight where you have the greatest adaptive capacity? And so you'll see if you're looking at all these webinars, you'll see a variety of ways that we use sometimes this very same data. So secondly, you have to quantify each of these elements. And so you gather your data, and then we create indices where we create essentially a score for exposure and sensitivity and ultimately impact and adaptive capacity. And then we put all of those together to represent vulnerability. Okay, so step one, gathering our data. I wanted to outline some of the criteria that we use to select our data sets. One, obviously, it had to be spatially explicit because that's the type of vulnerability assessment we're trying to conduct. Two, we needed to be available across most, if not all, of the focal landscape. So there's a lot of good information and studies, but they're at a more local scale than we could use for this assessment. Three, it needed to be meaningful. That's kind of, is it relevant to one of those measures of vulnerability? Is it meaningful that we can actually infer that there'd be some negative response or change in the status of a resource given this particular data set? We also needed to have enough information to measure uncertainty of the data set. Sometimes that was provided with the data. And this is so that we could identify options for reducing uncertainty. And then finally, we really tried to leverage the data and products that are already being used by LCC stakeholders and partners within this landscape. And that's to hopefully build upon what has already been created and not recreate the wheel, so to speak. And also, by leveraging what we have already, sometimes we're able to identify what we still need. You know, is what we have good enough to get where we need to go? So there's challenges with combining existing data sets, and I've highlighted a few of them here, and this is not the entire list, but these are some of the big ones that we ran into. First, the resolution and the scale of various data sets may differ, and they may not match management needs. And so when we were in that data gathering step, some of our criteria helped, I think, deal with this, but we've also selected an analysis unit here for the elk and mule deer. It's the Huck 12 watershed that we felt would give enough range, or would give us a good enough picture within this landscape of differences between different areas, but also wouldn't overspeak the capacity of the data sets that have built these indices. So some of them, you know, if they're quite coarse, you don't want to suddenly put out a 30-meter resolution product. And we felt that that resolution was probably good for some of the objectives of these assessments to identify common management needs. Secondly, there's a lot of uncertainties and assumptions within the underlying data sets, and they can vary. Some of this is due to knowledge gaps or inconsistent information, different methodologies, even different terminologies. And again, as we were going through the data sets, we really tried to use our criteria and selection to work through some of this. Some of this also will be dealt with this framework that we're using, the Vulnerability Assessment Framework, which is designed to deal with uncertainties and with combining a variety of data sets. And so during our upcoming adaptation forums, we are going to have a specific session to deal with uncertainties, and we'll talk about where uncertainties come from, and also there's a number of papers out there that talk about how we deal with uncertainties, and so we can explore those issues within each of the individual assessments and really start to identify ways that we want to handle that and move forward after. And then the final thing here, there's a lot of uncertainties related to climate projections, and so anybody that works with climate, you know, we're trying to predict the future, and there's a lot of variation on exactly what the future looks like depending on a variety of factors with the models and the particular mission scenarios and everything. And so the sources that we use in these assessments often incorporate their own method for reducing that uncertainty, but not always do they use the same method. And so where we could, we really try to, within a single assessment, use complementary data, and hopefully we were fairly successful with that. We'll also, when we have this further discussion of uncertainties, delve into this a little bit more. All right, we use a simple cumulative score type indice to begin the quantification of this data into something that represents those three elements: exposure, sensitivity, and adaptive capacity. As this simplified equation shows you, essentially each of the data sets that we use contributes 1 point to some final cumulative score. So the higher the score, the higher the exposure issue, or the higher the sensitivity, or in the case of adaptive capacity, the higher the adaptive capacity. So there's some pros and cons with using this kind of simple, non-weighted type of index. One, the pros, let's start there. They're easy to interpret. They're easy to manipulate on the fly. There's not any kind of black box issue going on here. They're also proven to be able to identify relative differences, particularly in landscape level analyses. They're fairly effective even when compared against more complicated methods. And you do have capacity to infer something about complicated interactions amongst your variables when you use it in a framework like a vulnerability assessment, where you have different elements that are summed and then compared. Some of the cons, though, are that these scores can be biased or misleading. They're only as good as the data that goes into them. And as part of the process, which I'll go into detail on the next slide, we are creating thresholds where we're saying that data of a certain value equals an exposure score of 1. And so those thresholds and criteria that we use influence this result. And so those, if they're not correct, then we may be introducing bias into this process. The simplified score also does not consider differential impacts, and it may be for some of these assessment targets that there is a particular issue that should be considered that have much more weight in these scores. And so as it is now, we don't have that. But as Zeidel starts talking about the data that's used, we do provide the opportunity, and you can comment anytime in the comment boxes with respect to that. If you have data sets that you think should be used or you think that there should be some weights used, that would be valuable information to have. So please feel free to add that. And then finally here, the way this score works is it assumes equal certainty and quality of the underlying data. And of course, data can vary and have various resolutions and all that good stuff. In a way, this isn't entirely bad because no one data set is driving any particular score. They're all treated equally. But if there are some real issues with the underlying data, that could be more of a problem. All right, and so here, oh good, there's my arrow. I'm showing you kind of the overall process, and we're detailing it for the exposure score. So along the bottom is the shorthand process from getting from data to your vulnerability map. And so I've just picked out a couple example data sets that we might use for exposure, departure, and temperature, and road density. And then we have to convert this information into a score. So we convert it into a 0-1 framework. So here I'm saying any increase in temperature, and we give a score of 1 to that particular watershed. Density, if it was in the top 25 percentile, we give a score of 1 to that watershed. And so where we find these thresholds, we did try our hardest to look in the literature and try to find some information that would help us delineate, what is significant, what isn't. Where we didn't have that information, we tried to use kind of objective thresholds so that we weren't incorporating any of our own opinions into there. And this would be great to get feedback on if somebody has information about how a threshold could be changed or modified to more accurately represent what we're going for here. So after you've created these scores, you add them all up and you get your exposure score. And so it'll just be a cumulative score. The higher the score, the more exposure. You've done a similar thing for sensitivity. I'm just not showing it here. And then ultimately you add the sensitivity and exposure scores to give you potential impact. And so it's going to be a range of numbers. And we've done this same process for adaptive capacity, though the data, of course, are things that are positive, that probably that we associate with increased coping capacity, et cetera. And we overlay these two things to get vulnerability. And so I'm just showing you a range of scores. So on our next slide, I'm going to show you how we actually represent vulnerability, because that's not an additive thing. So here we have our adaptive capacity scores from the lowest adaptive capacity to the highest. And then we have our impact scores. These have been rescaled, obviously, because you'll get a variety of numbers, so they're rescaled 1 to 5. But here's our low impact and our high impact. And so the way we use this is that we compare all the different combinations of adaptive capacity and impact to create this kind of matrix and distinguish on our map vulnerability from lowest to the very high. And so in this way, you can start to identify, and this is just a mock-up map. It's not a real one. You'll see some real ones in a moment. But we can identify areas that may be of high concern. Maybe there are areas that you're already working in, or maybe there are areas that will be new to you. So that's kind of how this is supposed to be used. So this is the last slide I'm going to show you, but it's just a variant on what we have put together, because for each of these elements, exposure, sensitivity, and adaptive capacity, they can be combined in various ways to get at various different patterns on our landscape. And so what you see here is a map that's showing us potential opportunities for management success. I guess that's the way I'm phrasing it now. And so we're using those same two summaries, but we could use different subsets of those data layers to get to the same place. But we're using those same two summaries, but in a different color scheme here, so that we're looking at the potential opportunities where we have the lowest opportunities where there's fairly high impact levels and low adaptive capacity, intermediate, and then the highest. And then that can give you a map that looks something like this. So where previously we saw some hotspots of vulnerability kind of up here, and all of the rest was low vulnerability, now we're starting to distinguish some things about those areas where there may be really best bet options or refugia for conservation or restoration actions. And so, with that, I'm going to turn it over to Zeidel.
Okay, thanks, Megan. Let me see. Okay. My screen is not advancing. Can you guys see? There we go. Okay. So I'm going to take you through a little bit of background on elk and mule deer within the focal area. Then I'm going to take you through the indicators we use for exposure sensitivity and adaptive capacity, and how we came up with vulnerability and impact. So just generally, throughout the area, both elk and mule deer are widely distributed across the focal area, across elevational gradients and a wide variety of habitat types within the area. They're mostly habitat generalists. They do have a few specialties within themselves, but that being mostly a generalist allows them to occupy such a wide range of habitats. But we know that winter and summer range are important. They do make seasonal migrations elevationally and use different habitats seasonally. Overall, both species are sensitive to development, and we do see a lot of these disturbances on winter range. Forage quality and forage availability are very important factors to them, as well as habitat fragmentation is becoming more of a high impact, and they're definitely sensitive to that. So if we take mule deer by themselves, they have a wide distribution across the West. They do mostly eat shrubs, although they will eat other forage when available, but prefer shrubs. Early cereal habitat is important. They do like open shrubby areas where they can browse that are near thermal cover, so they can hide from predators and keep warm. Just some quick history. They did go through some population fluctuations, and for a while there was a real worry about their decline, but they have sort of ebbed and flowed over time. It started in the 1860s, and there was Western settlement and introduced livestock grazing. We often saw areas that were overgrazed, which in turn changed the forage. There's also fire suppression, which really changed the landscape, and all those factors overall decreased populations. Then we had, more natural fire and some wet years that upped the forage quality. Therefore, the populations rebounded. And by the 1950s, they were fairly high, which within their range and populations, they created a lot of competition for resources and an overall lower carrying capacity across the landscape. And of course, there were areas that experienced different things, but this is the general story. Today, we have other factors that are impacting the populations that include fire suppression, which really, over a long period of time, has changed the landscape and available habitat. There is a lot less early cereal habitat available in some areas. Also, gas, oil, and mineral exploration has fragmented habitat. It's caused a lot of disturbance, introduced roads, and this is a concern, especially on winter range. We see urbanization impact from housing development and humans moving into a lot of these desirable areas that are backed up to Forest Service or BLM lands. And we're also seeing long-term impacts of drought on forage and habitat. Elk haven't experienced the population fluctuations as a whole to the degree that mule deer have. However, they have experienced populations in certain areas. fluctuations in certain areas. They mostly specialize on grasses and forbs. They have a larger body size and a bigger dietary range. For instance, they can nibble on some aspen twigs in the winter and stuff. But they do have a competitive advantage over mule deer. Their range does overlap with mule deer, although they do exploit higher elevational habitats and a broader range of habitats. They're just a little bit tougher than mule deer, therefore they can experience a range of conditions that perhaps mule deer cannot. For instance, they can withstand deeper snow conditions and colder conditions, but haven't been experiencing some of the same impacts, such as long-term fire suppression, which has changed habitat across the landscape. And overall, some general recommendations are to have a mosaic of conditions across the landscape, mid to late cereal forest conditions, interspersed with openings where they can forage and still be near thermal cover for survival in the winter, etc. Okay, so here on to the assessment. So as Megan mentioned, we have it in 3 parts in order to get to vulnerability and adaptive capacity. So we're going to begin with exposure, which are really what is impacting those species. And we have 4 indicators, including development and infrastructure, the change in development over time. We looked at a decrease in winter precipitation, especially in these southern areas like the Colorado Plateau and Rio Grande, because we may be getting more winter precipitation in rain instead of snow, as some models predict. And we also looked at soil and vegetation vulnerability as a proxy for the effects of drought. In sensitivity, we had 5 indicators, including roads, urbanization and impervious surface, vegetation cover, and area of summer range and winter range. And then adaptive capacity, we had changes in winter precipitation, the availability of water sources, which can be very important, especially in drier areas and during dry conditions. We looked at vegetation and thermal cover, as well as pinyon juniper woodland as habitat, because they really do use pinyon juniper woodlands year-round when they are available. We did use the HUC-12 watersheds as a unit of analysis, and you can see all of them here in the Southern Rockies LCC landscape. They do vary in size, but they are all, we're looking at our metrics within each watershed, and then you can prioritize based on where we see high, medium, and low impacts or vulnerability. We did have a lot of indicators on our so-called wish list. They just weren't available or weren't at the scale that we needed them to be in order to use them. And this included invasive species such as cheatgrass. We know it's a problem, and we know it can affect forage and have impacts, but it just wasn't a complete coverage for our landscape, and the data was sort of incompatible in the source that it was in. We also want to look at snowpack because we know that deep snow does limit them in some areas on winter range, so that's not yet incorporated. We know that chronic wasting disease is problematic in some areas. It's just incomplete and compatible at this time. We do feel that phenology and timing of green up is important because these animals do follow green up elevationally in the spring. It does help indicate their fawning and their movement elevationally. Fencing can be important, especially for mule deer. We weren't able to use that at this time. And we do have this riparian vulnerability indicator that we will be incorporating in the future. Riparian habitats are important, so we'd like to use that in the future. Okay, so exposure. We have our 4 indicators: development, change in development over time, changes in winter precipitation, and the soil vulnerability and vegetation change and drought effects. So how we used it, development, if it was present, we gave it a 1. So these 4 variables are going to be binary, right, zeros and ones within our HUC 12 watershed. If we look at development in the 4 corners, there it goes, 4 corners versus Upper Rio Grande, it's pretty similar across both areas. If we look at the change in development, which is predicted, both of these, let me go back to the first one, I guess, development, medium, high. We're looking at, we know that animals avoid areas and development reduces habitat availability. So we're interested in sort of having an indicator of habitat loss or land conversion that might introduce barriers to migration routes or some avoidance of the area. So we looked at these areas that have medium and high intensity % development within the area. And what this data did was sort of looked at land cover present in developed areas. So we calculated area in each watershed that had a change in development. So if it had development, we gave it a 1. So they are pretty similar between both areas. If you look at projected changes in development, again, it's looking at changes over time and quantifying that loss in land conversion due to development, which we know reduces habitat availability and increases fragmentation. So we looked at changes in development over time using the land use land cover data and quantified area in each watershed that's developed. So if it was developed, we gave it a score of 1. Predicted change, I guess they're not predicting much over time from what is current, so it's pretty low in the 4 corners and relatively low in URG. Changes in winter precipitation, we know that winter precip influences snowpack, spring green up and phenology, and spring forage availability and quality, and affects timing of calving. So we looked at whether that precipitation was increasing, decreasing, or no change over time. Mean annual precipitation, it's a 2030 projection of an ensemble of 17 models. It's called the RCP 4.5, which is a representative concentration pathway. So if it decreased, we gave it a score of 1, because that would be a negative exposure factor. And we see some huge differences between 4 Corners and Upper Rio Grande. 4 Corners is going to receive a lot of reduced winter precip. Well, URG, this is percent affected. So percent of the HUC 12 watersheds that are affected by this decrease in precip. So again, soil vulnerability and vegetation change over time. This data set was derived from Peterman and Furchweiler 2015. They reclassified a range of data and combined it here. So it's representing vegetation change and soil sensitivity factors for another ensemble model under the previous precip conditions for a time period of 2041 to 2050. So really it's combining soils data sets across the landscape and projected future vegetation and trying to get at a sense of soil sensitivity for the soil's ability to recover from disturbance. So they rank soils according to vulnerability. If they were vulnerable to at least one factor, we included it. If there was a change present, we gave it a 1. And both areas did see quite a bit of change with soil sensitivity over time. Okay. So if we take all of our exposure indicators, those 4, we put them into binary maps that were 0, 1, presence of absence of this indicator. We get an overall binary map. Trying to get back, there it is, okay, for the entire focal area, and you see it's by watershed. So then we can get this cumulative exposure by adding up the ones and zeros for all of our indicators. And we have, where did the clicker go? We have it low to high, so gray is low and red is high. And then let's look at our focal areas of the Four Corners and Upper Rio Grande individually. So red is high. We just only saw a few watersheds that had the real high. A lot of it was low to moderate exposure. So Four Corners had 24% of the HUCs were high exposure to the entire indice. Almost half was in moderate exposure and 31% low. Rio Grande, 13% was high, 25% was moderate, and 44% low. So you see over here sort of the Sangre de Cristos, the Rio Grande National Forest. Over here is like Flagstaff and Farmington, New Mexico, just to sort of orient you all. So that is exposure. Four Corners is definitely experiencing a higher percent, while the Upper Rio Grande is able to withstand a little more, perhaps because there's a variety of elevational types and habitat types, a little more so in the Upper Rio Grande than the Four Corners. Okay, next we're looking at sensitivity. So we had 5 indicators, including road density. We took the entire roads network, both primary and secondary, across this study area, and we looked at the quantiles of density and took the upper 25th percentile. So we know that roads fragment habitat, they can cause vehicle collisions and road-related mortalities. They are an indicator for development and disturbance. It can also be barriers to movement to seasonal habitats and also can fragment migrational corridors. So road density is a big indicator here. So if we take the area of road within the entire land area of the focal landscape, and then we took the top 25th percentile as a threshold, and any HUCs that contained over this threshold were given a score of 1. As you can see, percent affected within the Four Corners is a bit higher than the Upper Rio Grande. There's a lot of roads, density of roads in our area. Next, we use impervious surface. It is kind of an indicator of urbanization. So we looked at the percent developed and percent impervious within the area, because we know that urbanization decreases habitat quality, can fragment habitat, and we expect that these impacts are higher on winter range because there are places where people want to live in these valley bottoms, et cetera. We again looked at the quantiles and took the top 25th percentile as a threshold and then scored any of these watersheds with a 1 if they were above that threshold. So our goal was to really capture those watersheds that have highest relative urbanization or imperviousness compared to other watersheds within the area. Four Corners was at 32.7%, while Upper Rio Grande was at 24%. So a little more development and urbanization within the Four Corners. We looked at veg cover, percent veg cover using land fire, existing vegetation cover. We really grouped shrub, tree, and herb cover, anything between 40 and 70%. We know that veg cover is important as thermal cover from the elements, hiding from predators, and calving. So we included that, and we calculated percent cover of all 3 of those classes within a watershed. If a watershed had less than 40% cover, we classified that as low, and it was given a score of 1. And this is all based on, literature review that really said they prefer, both elk and mule deer prefer at least 40% cover when it's available. Four Corners did have a much lower, a greater amount of watersheds that had low cover, so less than 40%. But it is, the Colorado Plateau is a big part of the Four Corners, so there's a lot of like high desert environment and less, I would say, national forest area. The Upper Rio Grande had 44% of their watersheds classified as low cover. We also know that summer and winter range is important. This data came from sort of a sister analysis that worked with the Southern Rockies LCC. They took state-level range polygons, put them together as summer range and winter range across the whole Southern Rockies LCC landscape. The ones we are using today are for mule deer. We know there will be some overlap with elk. So if anybody knows of any full coverage layers of elk for the entire landscape, we'd love to hear about that. So summer range is important for foraging, calving, etc. We know that a mixture of cereal stages in a mosaic of cover with grassy openings and patches of mature trees is optimal. Some of the literature said there's a 60-40 forage to cover ratio that's optimal. Of course, there's leeway within study areas. So what we did was we took the area of summer range in meters and calculated the percent of the watershed that contained summer range. If that watershed contained summer range, we gave it a 1. If it did not, we gave it a 0. Same idea with winter range. We know that winter range habitat is important for overwinter survival, foraging, and they do need some thermal protection. So we did it the same way. We took the area of winter range, and if that watershed had any, we gave it a 1. You'll see the numbers are pretty low, especially in the Four Corners landscape. They're a little bit higher for summer range in the Upper Rio Grande. And we'll see why on this slide. All of the majority of both summer and winter range is north of our two focal areas. So here's Four Corners, here's Upper Rio Grande. And you'll see summer range here, winter range here. So a lot of it's north of here, which is why there's so small percents of hucks that actually have it. So just something to keep note of. It will sort of increase their sensitivity a bit because of this. So from this, we get a cumulative sensitivity, which we take our 5 indicators: row density, urbanization, our veg cover, and summer and winter range. And we can sort of do our additive 1s and 0s based on how we categorize them and get an overall map of sensitivity. So here is it broken down for our cumulative sensitivity index. Lighter is lower sensitivity, and redder is higher sensitivity. So again, the Four Corners has most of the hucks that are almost 42% at moderate sensitivity, while the Upper Rio Grande has a large portion of their hucks at lower sensitivity. So according to our factors, the Upper Rio Grande has lower sensitivity index, whereas in the Four Corners it has a much more higher proportion of ones in moderate. The good news is they have a little relative proportion in high. It's only 12% in the Upper Rio Grande and 25.8% in the Four Corners. Let's see. We have a question about, do we have a sense of how this data looks between the corridor of this winter and summer range? Not yet. We do want it. We know the data exists with that NASA developed project, but we could not find the layer, and we asked for it. I contacted the people several times to share the migrational corridor layer with me. So it's on our list of things we want, but we did not have it for today's analysis. Okay. Thirdly, adaptive capacity. So we had 4 indicators here. Again, our winter precipitation, our ensemble models for Rayfelt. Once more, we know that winter precipitation influenced snowpack, spring green up and phenology, and spring forage availability. So reduced precipitation could mean faster snowmelt, lower water availability, possible spring drought conditions, and forage availability and quality effects. So for adaptive capacity, we sort of took the inverse and said if there was an increase greater than 100% of normal, then the watershed was more resilient. If it had a decrease and less than 100%, it was less resilient. So again, it's mean annual precipitation percent of normal. So if it had a 1, then it was more resilient. So we see there are huge differences between Four Corners and Upper Rio Grande. Upper Rio Grande has more high elevational habitats, so maybe that was some of what accounted for the 71% increase, whereas Four Corners only had an 18% increase. Secondly, we looked at water availability, which we categorize as distance to water. We know from lit reviews that mule deer prefer to stay within 1.2 kilometers of a water source, especially in drier areas, whereas elk stay within 1.5 kilometers. So for this analysis, we used the 1.5 kilometers as a buffer around perennial streams. Water availability is important to both species for survival, especially when it's a limiting factor, and this could increase with climate change, especially in hotter and drier areas, and these desert and chaparral areas as well. So we put this 1.5 kilometer buffer around all streams, and then we calculated the area of a watershed that had greater than 10% of its area within this buffer. And if it had greater than 10% area, we gave it a 1. If it had less than 10%, we gave it a 0. So there's not too many differences between the focal area. We had at least 50% of the watersheds that had some area within that buffer to water. So that's good. These animals may be able to have some adaptive capacity when it comes to water sources. And this is not including man-made sources such as tanks, stuff of that nature. Thirdly, we looked at thermal cover. Again, we used this land fire vegetation cover. And we sort of flipped it in sensitivity. We saw if you had low cover, you got a score. Here, if you get high cover, we're giving you a score of 1. So we know that thermal cover is important for protection from elements, including hiding from predators, and it can moderate winter mortality. So we looked at our 3 classes, tree, shrub, and herb cover that were greater than 40%, and looked at the proportions of watershed that had at least 40% cover. Then we looked at them within the watershed, and if at least 60% of that watershed was classified of at least 40% cover, then we gave it a 1. So now we're looking at high cover. So its thermal cover is high if greater than 60% of that watershed had at least 40% cover. It was scored a 0 if it had less than 60%. So again, big differences between the 2 areas. There was only 7.8% within the Four Corners and almost 27% within the Upper Rio Grande. Lastly, we looked at pinyon juniper woodlands. We took our land fire existing vegetation type, and we sort of grouped all pinyon and juniper species together. So we're looking at, monospermia, osteospermia, and alligator juniper as well, and pinyon. We know that PJ woodlands provide important habitat. Some individuals use it year-round. It can be used as transitional habitat seasonally as well as winter habitat. So we gave it a threshold of at least 40% of the watershed had to contain PJ woodland veg type. So if it had greater than 40% of the area, we gave it a score, meaning we would classify it as more resilient. If it had less than 40% of the area classified as pinyon juniper, we gave it a 0, meaning less resilient. So Four Corners, there's a lot of area within pinyon juniper woodland. So they 20.5% of the hucks had pinyon juniper woodland, whereas only 12.7 had PJ in the Upper Rio Grande. Okay, so now we're on to cumulative adaptive capacity. So we took all of our 4 coded indicators as ones and zeros, winter precip, our water sources, distance to water, thermal cover, and PJ woodlands. And we can get sort of a sense of what it looks like on the entire landscape, low, and blue is high. So breaking it down by area, only 8.2% of the Four Corners had high adaptive capacity, whereas almost 78% had low. I think there's less areas that have high cover, and the distance to water was lower. In the Upper Rio Grande, we see almost 20% had high adaptive capacity, but a decent percent, almost 47%, had low adaptive capacity. So yeah, I mean, we can pick out the watersheds that have really low adaptive capacity. I should also note that, especially for areas that we included winter range, in sensitivity, that tribal lands were not included in this analysis for certain indicators that weren't that we couldn't get remotely sensed. So just keep that in mind. We just don't have on-the-ground data for tribal areas for this analysis. Okay, so now we can take all of our information that we just summed for exposure and sensitivity. We get an impact score, which Megan talked about earlier, where we have our adaptive capacity, and then we made an impact value. An impact is exposure plus sensitivity, so the first 2 that I talked about, and then we rank them by we have lowest, very low, low, intermediate, high, very high, and highest. We can actually code these watersheds based on this vulnerability, and then we can look at them as an area in the whole and find the watersheds that have the highest vulnerability and ones that have lower vulnerability, and then decide where we're going to focus our efforts. So breaking it down by our 2 areas, the Four Corners and the Upper Rio Grande, we can see that the Four Corners has most of its hucks that has a moderate capacity, moderately vulnerable, 28.5% in high and 17.5% in low. So if we look at our low, which is the green, if we look at the landscape, the San Juan River kind of flows through here. We have sort of the San Juan National Forest in this little area up here. Down here is Flagstaff and part of the Sitgreaves. If we look at the Upper Rio Grande, a relatively low proportion was in high vulnerability, 11.5%. Most of it, 33% was in moderate, and a relatively high proportion was in low vulnerability, which is good. And we see in the green here, that's our lowest. Sangre de Cristos are sort of up here and in here. So Carson National Forest and the Santa Fe National Forest over here. So we see some interesting trends here. I don't know if the Upper Rio Grande is more resilient because of its elevational differences and higher amount of different habitats within that area. We'll be looking into it more. But just to summarize our two study areas, the Upper Rio Grande had many watersheds with low vulnerability, almost 55%, while the Four Corners had many watersheds with moderate vulnerability. Winter and summer rains are limiting in both the Four Corners and Upper Rio Grande area, and again, we didn't have data for tribal lands. The Upper Rio Grande did have a higher mixture of habitat types and elevational ranges. The Four Corners had a bit less of that, definitely less forested habitat. The Upper Rio Grande had more high elevation habitat and more riparian habitat, while the Four Corners did have more PJ habitat across the landscape. As a whole, the Upper Rio Grande had a higher adaptive capacity. Four Corners had lower adaptive capacity. And if we just want to, again, remind ourselves of our exposure sensitivity, Upper Rio Grande had relatively low exposure, 44%, relatively low sensitivity, 61%, and had twice as much adaptive capacity as the Four Corners. The Four Corners had a moderate amount of exposure, a higher amount, 78% of low adaptive capacity, and that had 54% of its watersheds had moderate vulnerability. So we saw some interesting indicators, and we'll be working more to parse out why. So now
Awesome.
I'm going to hand it back to Megan.
All right, thank you, Zeidel. That was great. Okay, so we actually have used a good portion of our time here, so I'm going to whip through these next couple slides, and mainly it's just some closing thoughts. So I wanted to point out we're creating these estimates of exposure, sensitivity, and adaptive capacity for these focal resources. They can be used in a variety of ways. Assessing vulnerability and these potential opportunity areas, which I mentioned at the beginning, but will be more of a focus in the final reports as well. And really the point of this is to identify critical areas of interest or importance or priority within these landscapes. And that's where we hope to take this in our upcoming adaptation forums. I wanted to put a quick reminder out there, though, about how to use these products. They're not appropriate for local scale management decisions or conclusions, right? We're compiling all these data sets of various mechanisms, and really what the purpose and appropriate use for them are to look at these relative vulnerabilities across the landscapes and identify or prioritize, various needs, common areas of interest, and things like that. So, excuse me. So we want to use these assessments to identify management priorities. And as part of this webinar today and in preparing for, I think, the upcoming adaptation forums, I wanted to put these questions up here for you to consider as we move forward. And one, how do the results of these assessments match with where you're already working or your current priorities? We will, again, look at these in detail at the workshops and think about, is it giving us new information? Is it emphasizing what we already know? And then two, how can we use this information to move forward to develop collaborative actions within the LCC? And I have this cartoon here about innovation because I think that a lot of what natural resource managers and wildlife managers are being asked to do these days is going to require a lot of innovation and new ways to work together and new ways to think about and measure our problems. And so we really hope that these assessments are a step in the right direction with respect to that. And I do want to mention that we will have the actual written up vulnerability assessment reports which go into much greater detail about the individual variables and how they were created. It has maps, both showing vulnerabilities and opportunity areas. And we should have that out for the elk and mule deer assessment before the workshops. And another thing I want to mention, and Zeidel mentioned this, that we are going to use some of the results of the other assessments to contribute to the elk and mule deer assessment. So specifically, the vulnerability of riparian areas that Max talked about yesterday. We are incorporating those scores into an additional measure of potential exposure for this. And then we also have a pinyon juniper assessment that may have relevance because, again, there is this indication that pinyon juniper is a particular habitat of particular importance. And so, so I think at this point we can, well, I guess, John, I think you wanted to make some closing statements, and I'll switch to the last slide here.
Yeah. Right, Megan. Thank you very much. This is John Rice. I'm the science coordinator for the Southern Rockies LCC. And while y'all are formulating the questions that you have for Megan and Zeidel, I'd like to just mention a little bit about where we're going with these vulnerability assessments and what the next steps are going to be. So in outlining the exposure, sensitivity, and adaptive capacity here, that approach was identified by our steering committee as how they wanted us to initiate our look at landscape conservation design. And we did that because this is at least initially valuable information for those who are managing the resource. What we want to do next then is add to that the plausible adaptation actions that you might take in order to lessen that vulnerability, sensitivity, or increase the adaptive capacity. And we will probably be cataloging those into some form of what's called an adaptation library. And I say that because some of our partners are doing that already. We will synthesize various other efforts into a single database that can be used then to easily access those adaptation actions. And from that group of adaptation actions, we'll then work with the partners to develop conservation strategies that will facilitate the cooperative and collaborative work of the partnership to achieve the desired goals of the individual partners and the outcomes that they all would like to achieve. And while we have these vulnerability assessments that we presented to you today, I do want to thank you for your comments in advance and your questions in advance, because what we hope to do is refine these and then present them at the workshops. But at the workshops, we will also be looking at all of the vulnerability assessments together in order to look at those conservation opportunity areas that Megan mentioned. So without further ado, I will turn it over to you guys, Megan and Zeidel, to answer the questions that are coming up.
Yeah, okay. So, you know, I see, so Zeidel, do you mind if I answer this first question? I don't want to...
No, go right ahead.
Oh, well, and actually, I guess I could answer both, but maybe I'll have to defer to you if there's something.
Okay.
So, Garrett Hanks asked, was oil and gas development taken into consideration specifically? And so, Zeidel, I can't remember, but that is on our wish list of contributing factors in this assessment. And so if she didn't mention it, that is something that we want to include. And I think you're correct, because we have secondary and primary roads in our coverage right now. But there are some compilations of data that are at the entire LCC range, but they appear to maybe only represent BLM leases and things like that. And so we're trying to compile data from each of the individual states, and so that's a work in progress right now. Let me see what else you're like.
Yeah, one of the NLCD layers did have a mining, you know, like a percent mining, but we're looking for a more inclusive energy layer.
Yeah, the oil and gas. Yeah.
So if you have one that you'd like to suggest, please go ahead. Otherwise, it's on our radar.
Yeah, that would be great if somebody has this already processed. But that definitely seems to have some strong, it's a good indicator in the literature. And so with respect to this presentation, I do believe Mary is going to be getting this online, so you can re-listen to it if you wish in a recording, and I think she'll send that out to all the participants that were on here today as well. There'll be a PDF copy, so you can access that at any time. And please, we have our emails up here. You can write us if something occurs to you, you want to continue communication. That would be just fine too.
I'd also like to invite the audience to ask if anybody has a question by phone. Feel free to unmute yourself and ask that question at this time. All right, no questions by phone. We don't have any other questions in the queue. So we did plan to kind of go into 1:15. We do have a couple more minutes if somebody wants to type in a question or ask one by phone. And I had a little, I blinked out there with my computer, so hopefully the recording will be okay. But I will let everybody know via email the link to the recording, or if we lost it when my computer blinked out.
Okay.
All right. Nothing else. No more questions. So I guess Megan.
This is Andrew Black with the New Mexico Wildlife Federation.
Hi.
Hi. I was just kind of interested, as you all were kind of really trying to kind of pay attention to drought as well as kind of some of the bigger shocks out west. I mean, obviously, one of the big things that we're dealing with heavily in New Mexico is fires. And just kind of the ability of ecosystems to have the resilience to withstand that. And I'm kind of interested in what you all are, how do you take into account a fire that could be, fairly small like some of the recent ones we've had in New Mexico compared to a fire like Las Conchas that, just ripped through that area and had enormous devastation, or the ones down in the Gila. How are you all kind of, how do you kind of calculate for that and predict for those kind of things where you're having these fires that are just so massive, and what goes into that?
I have a quick answer. Go ahead.
Oh, yeah, I don't. Yeah, Zyla, you go ahead first, because I'm sure you.
Okay, so I was just going to mention, we can look at habitat in that summer or winter range, and then there is this wildfire hazard potential layer that we could incorporate, but that would be a habitat impact for mule deer. But I think your question had to do more with how is the landscape, how do we feel if it's more a resilience idea to fire, and I'll let Megan say what she was going to say.
Okay, well, I was just going to say, because we had this conversation between us about including some measure of fire impact within a watershed, and the issue that we come across, I think, and correct me if I'm wrong, Tyler, but that yes, certainly you can get these devastating fires that can abruptly change the landscape, and that would presumably have a negative impact, but when you actually go to the literature and you try to justify using indicator one way or another, you find that there's a lot of positive associations post-fire conditions and these browsing species because of the way the forage quality changes. And so I think that there was a bit of a conflict in, well, is it good or bad if something burns, and should we just include those areas that are likely to burn at a very high intensity? And some of that is hard to develop those data sets from what we have available, but yeah, the whole fire size or fire intensity and whether that's good or bad for the species, it's a matter of the time period that you're looking at. I guess my response is that there's no clean answer, and so we weren't able to translate that into this 0-1 score, and so if somebody has thoughts about that, we'd be happy to consider it, but as you know, it's difficult to say if you have higher fire potential in one area, is that truly a bad thing for the mule deer or elk if it increases forage quality and doesn't, and burns in a appropriate way so it's not removing everything above ground.
Right.
Yeah, correct. So elk would like it if it burned and more aspen came back, right? There's a lot of delicious forage with aspen, and then the other side was advocating, well, creating more early cereal habitat would be a good thing for mule deer because they really get a lot of forage there. So, yeah, it was tough to say either way because of long-term fire suppression, creating some early cereal habitats from fire would actually be beneficial.
All right. Any other questions by phone? Here's your last chance. As Megan said, you're welcome to contact those guys anytime if you have questions. So I'd like to go ahead and wrap things up. I will leave the webinar open a couple more minutes. In case you want to type something, we'll be sure to get that information to Megan and Zeidel if you have a comment or question. I'd like to thank everybody for taking the time to attend the webinar, and thanks to Megan and Zeidel for the great work. So goodbye, everyone, and have a great day.
Goodbye. Thank you.
Thank you.